Welcome to Physics 2212 Lab 1 Charge Tape. Introduction. The purpose of this lab is to determine the charge of a piece of tape using physics knowledge and calculations. We want to determine the amount of excess charge on a piece of tape. Models and fundamental physics principles. A charge is a particle that creates an electric field, and it's like the smallest unit, so it's like the atom of this kind of thinking. Particle interactions is when opposite charges attract and same charges repel. Coulomb's law is 1/4 pi epsilon naught times the absolute value of the two charges multiplied by each other over r squared. Electric field is 1/4 pi epsilon naught times the absolute value of q over r squared, and then the force of an electric field is F times EQ, and the force of gravity is mg. Review of main results. The tape had an excess charge of 9.2 times 10 to the minus 6. Lab. System and surrounding. The system is the charged tape moved towards the other charged tape, so the one at the bottom. The surrounding is everything else. So the second charged tape that is across the two pillars, just the hands, everything else. Initial conjunctions, both of the tapes are charged with a positive charge. Details of experiment. Made two U-tapes by quickly removing one piece of tape from another. Held one U-tape across two pillars and the other U-tape directly underneath, and then measured the distance between them. Down here in the bottom left corner, we have the calculations to find the charge of the tape. So first, we had to find the force of gravity, and then found the specific charge on the tape, and then the number of electrons, the number of atoms, and then that ratio is our final answer. And then here are the pictures from lab, showing the charged tapes. Details of code. The most important pieces of code are the initial vector locations, and then also the calculation of the electric field. Questions. What was the magnitude of the charge of one piece of tape as calculated by a computational model? That was 3.7 times 10 to the negative 10. So that was a little bit smaller in magnitude than the calculated in class version. And then to do that with the computer model, we had to ignore error resistance, treat the tape as a point charge, and assume that the U-tape had equal amount of charge across the length of the tape, which in real life is not true, but it helps simplify the calculations in the computational model. Analysis. The differences between the lab and the code. The code doesn't have any charges that dissipate. It should in general be more accurate, but then it also makes a lot more assumptions, like the charge being uniform across the piece of tape, and electrons don't act perfectly in all situations. Sources of error in the lab. The charges of the tape dissipating, the tape not being uniformly charged, measurement errors with the amount the tape moved, and then of course human error with how we viewed it. What if and what does it mean? For the first question, the observations would be reversed. So any attractive things we saw would be instead repelled, because the tapes would be negatively charged then, and then the negatively charged tapes would repel away from things. And then why is it important to handle the charged tapes as little as possible? That's to make sure that the charges don't dissipate. And what happens when the charges interact with your hands or other objects is that the charges become weaker, and that the charges spread out and do not become polarized. Thank you. That's it for the lab.